Good morning. Welcome to the next topic, classification of semiconductors. So as we see from the diagram, so these are the difference between the insulator, semiconductor and conductor. If you see the insulator, we'll have two band, conduction band, valence band. Valence band is completely filled with electrons. Conduction band is empty. If you see for the three cases. And if you see the band gap for the insulators is very large. Band gap is nothing but it is an energy band gap between the conduction band and the valence band. So electrons required more energy, or we can say it cannot escape from the valence band to the conduction band because band gap level is more. So that's what it is called as insulator. If we take the semiconductor, the band gap between the conduction band and the valence band is very small. So when temperature increases or impurity is given, it is easy for the electron to move from the valence band to the conduction band. So that's what it is called as semiconductor. So it will have narrow band gap. Third case, if you see the conductor, there is no energy gap. It get overlap. That is conduction band and the valence band overlap with each other. So conductivity will be more. So no band gap will be present here. So that's what we are calling it as a conductive material. So if it comes to the classification of semiconductor, already we know the band gap is very small. So it is easy when external energy is applied. It is easy to move the electrons from the valence band to the conduction band for the conductivity process. So it is divided into two: intrinsic semiconductor, extrinsic semiconductor. That is, intrinsic semiconductor is nothing but pure form of what? Germanium silicon, and here density of the electrons is equal to density of holes. If you see the extrinsic semiconductor, it is of two types, N-type and P-type. N-type is nothing but adding impurity atom. That is, if we add pentavalent impurity atom to intrinsic semiconductor, it is called as N-type. And P-type is nothing but if we add trivalent impurity atom to the intrinsic semiconductor, and it is called as P-type semiconductor. Next, let us see about the intrinsic semiconductor. So intrinsic semiconductor, it is nothing but it is a pure form and is made up of only single type of element, either silicon or either it can be germanium. If we see the band diagram of the intrinsic semiconductor, Ks1 at T is equal to 0 Kelvin. If we see the A diagram, that is nothing but band gap energy is there, that is small band gap between the conduction and valence band, and the valence band it is completely filled, and in the conduction band it is empty. So no conductivity will take place. If you see the case B, when the temperature increases, see the electrons gains the energy and moves from the valence band to the conduction band. So conductivity will get started. Next, extrinsic semiconductor. Extrinsic is nothing but adding impurities, that is nothing but by doping process we have the extrinsic semiconductor. And we will have N-type and P-type semiconductor. Already we know N-type semiconductor is nothing but adding pentavalent impurity atom to the intrinsic semiconductor, it is called N-type. So it donates the electrons, so donor energy level. If we see the P-type semiconductor adding trivalent impurity atom to the intrinsic semiconductor, it is called P-type semiconductor. Here it will accept the electron, so it is called as acceptor energy. So this is the difference between the intrinsic and extrinsic semiconductor. Pure form, extrinsic, impure form. Here the density of electron is equal to the density of holes. Here the density of the electron is not equal to the density of holes. Here electrical conductivity is low. Here the electrical conductivity is high. Here it depends upon the temperature only. It depends upon temperature as well as impurity. So no impurity for intrinsic. Extrinsic means adding trivalent or pentavalent impurity atom. So application of semiconductor, we can, most of the electronic devices is made up of semiconductor material. So we can use it in the transistor, diodes, photosensors, microcontrollers, integrated chips, and much more we can use it in the semiconducting material. Thank you.